Solve the literal equation below for x. Okay, so ax plus b equals c is a literal equation because it's all letters. Now, the way that you want to solve it is using a simpler analogous equation like 3x plus 2 equals 17, so that you could compare the process and think about how you want to do it. Okay, so we're going to start with the easier problem, where we know we would always want to be using PEMDAS backward, right? Any addition, subtraction goes first. So we see plus 2, we know the inverse of addition is subtraction. We're going to do minus 2 on both sides. This makes the 2's cancel, and we're down to 3x equals 17 minus 2, or 15. Okay, before we go too much further, now we want to compare it to the literal equation, the one with all the letters. We're going to use the same process. You could see in place of the 2, we have the letter b. The inverse of addition is still subtraction. We're going to do minus b on both sides. It doesn't really matter what b is. Positive and negative b will definitely cancel. The only difference is we can't subtract, like 17 minus 2 gave us 15. We don't know what c minus b is, so we need to leave it as the expression c minus b. Okay, let's go back to our simpler analogous problem. We're still looking for x, and what we would do next is any multiplication division. Any number sitting next to a variable implies multiplication. The inverse will be division, so we're going to divide by that number by 3 on both sides, and that gives us that x is 5. Okay, so let's do that over here. In the place of 3, we had the letter a. We can see it's attached by multiplication, so we can still use the inverse operation of division. A divided by a will still cancel. We got x alone, but we can't really simplify this expression any further than it already is. We had c minus b from the first step, and we divided that expression by a. So when we work a literal equation, we're not going to get a numerical answer, like an answer that's a value, like we normally do. We're going to get an answer that's just an expression for x.